Now, in these questions, the idea here is that we've given our two expressions that we want to start with one and prove that it's equal to the other expression. So basically, you're being given the answer and you need to simplify what you've got on one side through to get the other. Now, it's not an idea that you can start playing with both at the same time. That's not the idea. What the idea with this one is that, again, the question's being nice and giving you what it wants you to simplify something to. So we need to keep it in mind, but not play around with it. So the idea here is to start with our cosine squared x minus 1 as our left-hand side, and that's what the LHS stands for. Start with your left-hand side of your expression and prove that you can come down and equal to your right-hand side of your expression. So, cos squared x minus 1. Now, when I've got this one, well, normally if I'd have 1 minus cos squared x, so if I manipulate that and factorise a negative out the front, so factorise a negative 1 out the front, that gives me minus out the front of 1 minus cos squared x, which I know is equal to, in our relationship, sine squared x, which is what we wanted to find. So it's not as if I'm ignoring it. I'm keeping it in mind to know what I will need to manipulate through to get, and we'll see that more as we go through. But we don't play around with it on both sides at the same time. That starts to get a little bit messy. So the next one, we start with our left-hand side, 3 plus 3 tan squared theta. And I see that I want to get sine in there, so I know I need to manipulate it somehow. So I factorise the 3 out. Gives me 1 plus tan squared theta. Now I know 1 plus tan squared theta is equal to secant squared theta, which is cos squared theta, 3 on cos squared theta. When I know cos squared theta is the same as 1 minus sine squared theta, which is what I wanted. So again, I kept in mind that 1 minus cos squared theta is equal to cos squared theta. Once I saw the sec squared theta appearing there, I knew I was on the right track. Is that the only way to do that question? Possibly not. Possibly not. We could have started with tan being sine on cos and then start to manipulate it there. Doable. Might be a little bit harder. This is probably what we'd call the most elegant solution because it's the simplest one. There may be simpler ones though. But that's what we're looking at. We're trying to get there in the least hardest way. So trying to save us from doing too much work. Now, this one's a little bit different, and you can see why. If I start manipulating the left-hand side here, I get secant squared x minus tan squared x. Well, secant squared x is equal to 1 minus tan squared x, and no, minus tan squared x gives me 1. I haven't got too much to go to once I've got 1. So once I got to that point, I went, well, let's start working with the right-hand side. It's not the way I'd like to normally go, but this one sort of needed to do that because I got down to 1. So manipulating cosec squared x and cot squared x. Well, cosec squared x is 1 plus cot squared x, and the cot squared x is cancelled, gives us 1. So I've got down to a point where that expression is equal to 1 and that expression is equal to 1. So I can say that my left-hand side is equal to my right-hand side. Not, as I said, not the normal way I want to go, but it was necessary in this case because I got down to a point where I got 1. Starting with the left-hand side, working to the right-hand side. Well, that's not easy. But let's have a look. We get the left-hand side, and because I look at that one, I can't do too much changing and doing that. So, but then I realize I've got the difference of 2 cubes, which I can use my rules there and factorize. So that would give me the sine x minus cos x, and we get sine squared x plus sine x cos x plus cos squared x. That's just a difference of 2 cubes. If we remember that rule, we can manipulate it and get that part. But then I see that I got sine squared x and cos squared x. So those two add up to give me 1. Plus the sine squared x, sine x cos x, which I can then expand out again. So sine x minus cos x, sine times sine is sine squared, cos times cos gives me cos squared, which is to at the expression that we wanted to get, is our right hand side. So factorise first, simplified with sine squared x and plus cos squared x, and then got down to our right hand side. Question 5, here we get cosine squared of 90 minus theta times cot theta. Well, hopefully we realise, remember our complementary, that cos of 90 minus theta is sine of theta. And then we can start to manipulate cot to be cos on sine. So we're in terms of sine, and our final answer is in terms of sine and cos, and there's no cot there. I need to convert cot into cos on sine, and then sines cancel, gives us sine times cos, which is equal to the right hand side. Now when we look at cotangents, cotangent and tangent are ones where we can go a number of ways, because I know cotangent's cos on sine. Cotangent also can be written as 1 on cot, or 1 on tan. So there's a few ways we can go about some of these expressions. Some, again, will be harder, some will be not so hard, and some will lead us up the wrong path, and we'll have to come back and start again. Again, experience plays a big part in this, in that your manipulations that you can do so oftentimes relies on the path you take being part of the experience, part of your experience, to know which one to go on. So because I looked at the right hand side here and realised there was no cotangent or tangent, it was, the final answer was in terms of sine and cos. That's why I went from cot to be cos on sine and not 1 on tan. So keep that in mind as you go through. Again, when we're trying not to have to use this side, but we keep it in mind what we want to end up with. So this time 1 minus 10x all squared plus 1 plus 10x all squared. Keep in mind what we've got to finish with is sec squared. So we can't do any factorisation of the left hand side. So we expand it out. 1 minus 10, and I'm sorry I changed to theta at some stage here. So I shouldn't really do that, but realise it's just in the same variable. And we get, once we get that expansions of both, just expand those binomials and collecting our terms, we get those cancelling. So 2 plus 2 tan squared theta, which we can factorise the 2 out, gives us 1 plus tan squared theta, which is equal to 2 sec squared theta, which is what we wanted. Question 7 here. This is going to take, when you even look at this one looks hard, because it looks like there's a bit of manipulation going on. Cot x plus cosec x all squared. So what we've got here, take our left hand side, expand it out. And because I'm going to go to cosine of x, I really need to change cotangent and cosecant there. So we get that manipulation, we get the cos on sine, cot is cos on sine, 1 on sine and 1 on sine there, which that nicely gives us the same denominator in each, sine squared of x. So that works out nicely. So that's where we get the cosine squared plus 2 cos x plus 1. Now, and we want to get 1 minus cos on the bottom. So I don't really want sine squared on the bottom. So that's why we manipulate to get 1 minus cos squared x on the bottom there, because we know that's what sine squared x is equal to. And we know we want it all being cos of x. Now, for this part, that would be the difference of two squares, 1 minus cos x, 1 plus cos x, 1 minus cos x. Because we know that's the difference of two squares. And this is actually a perfect square. It's 1 plus cos x all squared. I know I've manipulated to put the 1 in front. Doesn't really matter. But then we can see that the 1 minus cos x squared divides by the 1 plus cos x, which just means that's going to cancel there with the squared. And we got the 1 minus cos x, which is our right hand side. Have a look through again. Make sure you know what happens in every line of that manipulation to get down to that one. It's not easier, it's getting harder in that respect, because there's more manipulations, especially with our factorizations here, to get from this point to this point. Again, another one that looks reasonably hard. Doesn't look reasonably, it looks very hard. Let's start with our left hand side with sine of theta, 1 plus tan theta, cos theta, 1 plus cot theta. Again, we want it all in terms of sine and cos. So the tan and cot are going to have to change to sine and cos. So this, we've done that manipulation first up. Expanded our brackets because there's nothing really we can factorize as such. So we get sine theta, sine squared theta on cos theta, cos squared theta on sine theta there. Nothing we can simplify yet, but we've got fractions, so we need a common denominator. So everything needs to be in terms of sine and cos. So this needs to be multiplied by sine times cos. So that's where the sine squared theta, cos squared theta comes from. This one just needs to be multiplied by sine squared theta, so we get a sine cubed theta. This one needs to be multiplied by both sine and cos, so that's where we get cos squared theta and sine theta. And the last one just needs to be multiplied by cos, so that's where we get the cos cubed theta. I've manipulated this one, just moved some things around, so cos, sine squared theta, cos theta, it moves up the front, and I've just moved the cos theta, cos cube theta there, sine theta, cube theta. And because I know I want to get the sine theta, and because I know I've got my denominator in place. Beautiful, that's nice. I'm already there with the denominator, but this needs to manipulate down. So it means I need to be able to cancel a few things or do something with that. So when I look at this, there's lots of start to look at things that are common. It's nothing common right the way through. So what I try and do is, well, let's group them in some pairs and see what happens. So that's where I got the sine theta, square theta, cos theta. And was able to factorize a cos theta out because there's nothing much more I can do. I could probably manipulate it a different way, but this was one of the better ways. So because I know that's going to become 1, and I factorize the sine theta out of this one, and that one nicely becomes 1 as well. So you see where I manipulated to get something out. So in my brackets I'd have the sine squared theta plus cos squared theta. Once I saw all these powers of sine and cos, I was hoping I could do that. That was my cunning plan, was to get something with sine squared theta and cos squared theta in there, because I know that's going to manipulate down to be equal to 1. So that was what my problem solving experience told me that would be the nicer way to go about it, is to try and manipulate it because of all those powers of sine and cos existing there. And I knew it had to simplify down. So, and that leaves us with just the cos theta times 1 plus sine theta times 1, which is exactly what we wanted on our right hand side. So we were able to prove that. So there's what we need to do to solve a lot of these problems. Remember, we start with our left hand side, we move to our, and we keep in mind what our right hand side looks like, so we can start to manipulate that left hand side to get to what we want. Sometimes it's going to be easy, sometimes it's going to be hard. As you see, the last two questions there were hard. So you may need to go back through those carefully to understand exactly what we're doing, and looking at our algebraic techniques of fractions and then factorization to be able to solve these problems. Because you need to be able to do those well to solve some of these harder problems.